Okay, we're going to do Unit 5 right now. It's all about exponents. I've kind of got this one summary sheet, and this is really kind of everything that we need to know about exponents. The big thing that we need to know about exponents, there we go. When we write we have a group of exponents, a bunch of bases and exponents together. The rules are, what we're really trying to do is have no repeated bases. And only positive exponents. So we don't want any zeros, we don't want any negative exponents when we do this. So this is all the tools that we're going to have to accomplish that. Number one is the product rule. So the product rule, basically just we add together the exponents. Here it is in the math terms. We just can add together the exponents if we have the same basis. Must be the exact same base. Must be the exact same base. But there, I think you've seen that before. So good example, like example A, x to the third, x to the eighth, x to the 11th. The next one is the quotient rule. If we have an exponent in the numerator, or I'm sorry, base in the numerator, base in the denominator, we would have, we can just subtract them. Now, yeah, that's good. So we just, like the examples we have here. Now you may, after you subtract this, end up with a negative exponents, and you'll have to deal with that as well. But there's some good examples of what you have to do. Maybe we'll have multiple, like in option C there, maybe in problem C, we might have more than one variable. Zero exponent is pretty much the same. It just means anything to the zero power is 1, and that's kind of comes from the quotient rule, actually. So if you had, let's say, x to the 10th over over x to the 10th, well, anything divided by itself is 1, right? If I use the quotient rule, that would be x to the 10th minus 10th, which is also x to the 0. So that way we get the concept that x to the 0 is 1. It's kind of how they kind of come together. Watch the parentheses. So here you got a parentheses, everything going on there, all kinds of stuff going on, but it's all to the 0 power, so that would be 1. If I had a problem that looked like this, let's say I had 5, x to the 5th, y to the 10th, z to the 3rd to the 0 power, well, that's going to be 5 times 1, or 5. So remember, it only applies to what's in those parentheses in that situation. The power rule, or the power of a power rule. 4 and 5 are kind of the same thing. The power rule, the extended power rule. I just call it the power of a power because it sounds more like, I don't know, I'm in the Avengers or something like that. But anyway, if I'm taking a power to a power, you don't see the base repeated. You just see the base to a power to a higher power. You multiply those exponents. The thing is, though, in the expanded power rule, you got to hit everything that's inside those parentheses. So, for example, this A is a good example. There's a 2 there. That looks like a coefficient. Oftentimes, we will forget that to take that to the power, but we're actually taking. Wow, sorry. We're taking 2 to the 3rd power and A to the 3rd power. It feels like you're distributing. It feels like you're like this is 2 to the 1st and this is A to the 1st, and you're distributing that 3. That's not really the math word, though. That's not really. This is the power rule. This is exponents. So it's not. It's got that feel to it, but it's not. I like B. That's a good. I was like B. Same thing. We got a coefficient there. Same thing. I like C and D. Same thing. If they're in a, if you have a quotient going on, you have to hit everything. And maybe there's stuff going on inside here that you might have to do quotient rule first, or the power rule first, or reduce it first. Do that first, then do the power rule. I guess it doesn't matter, but you can. The next one is negative exponent rule. Now, think about negative exponents, and we said we aren't allowed to have negative exponents. That's the first thing I said, one of the first things I said. So I would say it's got to move. So here's the rules, the math rules right up here. I've always said it's got to move. So if it's in the numerator, think about it like this, over 1, it's in the numerator, it's got to go. So it's in the numerator, it's got to become positive because we can't have negative exponents. So go from the numerator to the denominator to become positive. Same thing for if it's negative in the denominator. If the exponent is negative in the denominator, move it up to the numerator. So like this is over 1. If it's a negative exponent, it's got to go. Do not confuse this with the negative value in front. A lot of people, like if it was, let's say, negative x to the fourth, that's not a negative exponent. That's just a negative coefficient, right? That's like a negative 1 in front of there. That doesn't have to move. But if this 4 was negative, that would be a whole different thing. Then it would have to go. Okay, so that's the one thing that happens all the time. The other rule, I like this right here. This we don't use this as much as we should. But if we've got a negative exponent for a quotient, we can just take the reciprocal of what's inside and change it to positive, and that takes care of itself. You could take each one, you could do the power rule and take them to a negative exponent and then flip it if you wanted to then move it with these rules here, with the negative rules here. But that's kind of, that's up to you. There's a lot the thing about these is there's different ways. It's not like order of operations where you have to do it in this way. You can use the different rules as long as you don't break the rules, as long as you don't apply them inaccurately. You can use them any way you need to. All right, I'm going to post this note sheet for sure. It's a good thing to just have. I guess you already do have. I guess it's already posted. But this is a good reference to have. So why don't we do a few together? Let's maybe do a couple of the hard ones together. So let's go down to, let's see, well, let's do kind of some of each. So this one here looks a lot like product rule to me. We're multiplying straight across. Don't forget to multiply the coefficients. 4 times 2 is 8. X to the 3 plus 3. So that is 8x to the 6th. Kind of a product rule. Okay. Let's see. Here's a quotient rule. We've got this always is going to start in the numerator. So it's going to be 6 to the 5 minus 3. That's going to be 6 squared. 36, but we're talking about exponents, so I guess I probably should have left it as 6 squared. I like number 6. Number 6 kind of remember stuff. This is going to be x to the 4 minus 7. Like I said, we're always going to start in the numerator. So this is x to the negative third. It is a negative exponent. It's got to move, so you can think about it like that. So we need 1 over x cubed. It's got to go. Got to go. 8 I kind of reminded you of. That's like saying negative 1 times all that to the 0 power. So that's negative 1 times 1 or just negative 1. Watch your signs on this. Big deal on this. Number 10. I like number 10. Make sure you're hitting both. Easy to forget that there's 2 terms inside of there. So this is going to be x to the 2 times 4, y to the 1 times 4. So x to the 8th, y to the 4th. Be honest, that one doesn't seem to be a problem. Those ones, it's when I have a coefficient right here is when students tend to forget to hit everything inside. So I would worry about that one. I like 13. I like 13. So we got a lot going on 13. So you know what? Let's do 14 since it's the same thing and I got more space. So 2 to the 4th, f to the 4th, g, because there's a 1 there, g to the 4 times 4, so g to the 16th, times f to the 6th, g to the 6th. So I went through the first time, did all the power rule that I could do. All right, now I'm going to use my product rule. Well, 2 to the 4th, that's just 16. If you left that as 2 to the 4th, I would be fine with that. it's such a small number, 16. So I would like if it's less than 100, I would probably just write the number. But we are in the exponents chapter, so if you left it as 2 to the 4th, whatever. I think I've always said in the past, if it's less than 1,000, give me the number. But if it's like 5 to the 8th power, that's what we're using. We that's some crazy number. That's what we're using exponents for in this chapter. So how many f's do we have? Well, we got f. We got 4 plus 6, so we have 10. I got g to the 22nd power. All right. Any other fun ones? Ooh, I like number 17. I like number 17. So everything's to the 3rd power. Now for me, I'm going to do everything in here first. I can see I've got multiple x's, multiple y's. I'm going to reduce that. That's going to make my life a whole lot easier. So 4 over 16, well, that's just 1/4. So 1/4. I got x to the 5 minus 1 is going to be x to the 4th. Y to the 1 minus 4 is -3. All that to the 3rd power. Well, just to make that look a little bit more proper, x to the 4th over 4y cubed. We had to go to the other place. Cubed. Now I just have to say that's going to be x to the 4 times 3 is 12. 4 to the 3rd, don't forget that. Y to the 9th. And you can even say 4 to the 3rd is 64. Wonder which one's the answer key says. Yeah, the answer key says 64. So there you go. I think reducing it on the inside is the way to go. Maybe try number 18 right now and see if you can check your answer with the bottom to see what's going on. Definitely number 19 is pretty simple. It's got to move. Was a good one to point out. Number 21, it's got to move. It's in the denominator. It's got to move to the numerator. I like 26. We're going to add, that's going to be j to the -13 plus 4 plus 6. So that's j to the -3rd. It's got to move. No negative exponents. J cubed. 1 over j cubed. Let's see. That's all kind of similar. I think we've got kind of enough. Number 30. Ooh, I like 30. So this is going to be, let's do 28. We'll go back to 28. So this is going to be x to the -4 minus -9. Watch your signs. So that's going to be x to -4 plus 9. It's just x to the 5th. Nothing to move after that one. Okay? Number 28 is the same thing, but it's just that reduces. So this is going to be 4 x to the 6th minus -7. So 4 x to the 13th. I'm a little less excited about that one as I thought I was going to be. All right. How would I go about number 33? I think what I would do is I would do because there's negatives and positives on the inside. So I would say, okay, this is going to be 2 to the -2nd, x to the -6th, y to the 6th. So now I'm just going to move what I need to move. Well, the y to the 6th is going to stay up there. And then this is going to be 2 squared, x to the 6th in the denominator. And of course, 2 squared is 4. No, I ran out of space. So y to the 6th over 4x to the 6th. So I would take either one of those. That looks pretty good. Let's take a look at 37. I like 37. 37 is a bring it all together kind of a problem. All right, I've got this negative exponent out here. So what I'm going to do first, though, is I'm going to clean up what's going on the inside. So 7/3 is the coefficient there. So that's going to stay -7 cubed. All right, I've got a to the 2 minus 3, so a to the negative first, b to the 3/4, so that's going to be, or 3 minus 4, so that's going to be -1. C to the 0 is gone, so then C to the third can just stay down here. Or I could have said quotient rule, 0 minus 3, -3 in the top, but it's the same thing. All of this to the -4th equals, let's just clean that up again. So all that's going to go to the bottom. So it's going to be -7 over 3. A comes down, B comes down, C stays there. All that to the -4th. Now it's negative. So we can do that switch rule, that reciprocal rule. So we're going to say, okay, 3abc cubed can go to the numerator, -7 to the denominator, and now it's not all to the -4th, it's all to the 4th. Now when I take it to the 4th, I'm going to have 3 to the 4th, a to the 4th, b to the 4th, c to the 12th, all over, now be careful here, -7 to the 4th. What's 7 to the 4th? That's probably a pretty big number. 2001. But anyway, okay. So that's going to be, I'm going to leave that as the next one. So this is going to be 81, a to the 4th, b to the 4th, c to the 12th. But one thing you can get rid of is that negative. It's to the 4th power. I'm curious what they did in the, well, they did. They just brought it. It's to the negative. It's a negative to an even power. So you could say either 7 to the 4th, or you can write out 2004-01. I'd take either answer. But remember, the negative goes away. It's a negative number to the 4th power, so it would be not negative. It'd be positive now. All right, that's some good practice. Let's move on to let's go to the second notes, and we're going to talk about scientific notation. You've probably seen this, but let's just do it anyway. So write a number in standard form. It's in scientific notation. It means that 8 there means I'm dealing with 8 decimal places. So I got to count over. So I'm going to go with my 4.94. I'm going to go 1, 2. I need 3, 4, 5, 6, 7, 8 decimal places. So it looks like that's going to be 494 million. This one we're going the opposite way. So I got my 1.8. I got to go 1 up. I need 1, 2, 3, 4, 5. How many did I go? 1, 2, 3, 4, 5, 6. There's my, kind of get rid of this and this. So 0.0005018 is how we would express that as an actual number. I don't believe we do this in Algebra 1 anymore, so might be somewhat of a review. 9 to the 6, so 9, 1, 2, 3, 4, 5, 6, 9 million. And this one we're going to go 3, so 1, we need 0.12142. 1, 2, 3. That's how many went. All right, going the other way. I know that I've got to bring this all the way back. I'm writing this number in scientific notation. I know I want my decimal point here. So it's going to be 7.8 times 1, 2, 3, 4, 5, 6 times 10 to the 6th. If it's a large number and you're expressing it in scientific notation, you got to have a positive exponent. If it's a small number, you've got to have a negative. You know, let's do the small number. So we need 1, 2, 3, 4. This is going to be 3 times 10 to the -4th. Tiny, tiny number, and we're expressing it in scientific notation. All right. How about this one? 1, 2, 3, 4. I moved the decimal point 4 places, but it needs to be 9.5 times 10 to the +4th. And the last one, 5.05 times 10 to the 1, 2, 3, 4, 5, 6, the -6th. Feel like the count on Sesame Street. I don't even know if you guys ever watched Sesame Street, but there was a count. Never mind. All right, let's talk about multiplying numbers in scientific notation. So when I see people do this, they sometimes will just We're going to multiply, divide, and take them to the powers. They just kind of just use the calculator, or they just, I don't know, they do whatever. So what I'm going to do is I'm going to multiply 9.81 times 2.69. I'm going to multiply these two guys together here. I get 26.3, I'm going to round to 2 decimal places, 39 times 10, and I'm going to use the power rule now. 0 plus 3 is 3. Now that looks great, but what's wrong with that is it's not scientific notation. I have to move this here one place to 2.6, and I can keep all 39, times 10 to the, if I'm going left, I have to add 1. That's going to be 2.639 times 10 to the 4th. All right. Let's try this one. 3.2 times 7.19. I get 23.008. Really pretty much 008. Let's just say 23. I guess it's 001, isn't it? You round correctly. Times 10 to the 5 plus negative 3. So that's 23.01 times 10 to the second power. But again, that's not scientific notation. The number here has to be between, less than 10 and 1 or greater. So we got to have it be 2.301 times 10 to the third. We had to move it once. All right. Really, it's the product rule. Comes down to the product rule. Let's do number 11. All right, we're going to divide here. So I got 9.1 divided by 3.7. I get 2.46 all around times 10, and I got a 4 and a 3, 4 minus a 3, so 2.46 times 10 to the first power. And that would be just 24.6, but whatever, we're not going to do that. But let's try the next one. Now I got 2 divided by 8.22. I get 0.243 times 10. I got negative 6 minus 2. So it's going to be 2.43 times 10 to the negative 8. So now I got to move this way. So I got 2.43 times 10. So instead, this is going to be the opposite. Instead of adding 1 to it, I have to subtract. So it turns out this is going to be to the negative 9th. I had a very small number, and I made it even smaller-ish, you would say. I moved that decimal point to the right, so I have to subtract 1. All right, that's those 4. All right, one more. Now this one is kind of the same. Let's do 14, then we'll do 13. So 4.3, this is kind of, because this is times in the middle. So this is really 4.3 to the 6th times 10 to the 6th to the 6th. So 4.3 to the 6th. Wow, I got 6321. I'll just round to that. Times 10 to the 36, right? But I got to move this 1, 2, 3. So I have to add 3 here. So I got 6.321 times 10 to the 39th power. That's a rather large number. What if it's a negative number? Well, same thing. 8 to the negative third times 10 to the negative 6 is what it's going to be. So 8 to the negative third, that's going to be 0.00195, let's say, times 10 to the negative 6th. I got to move that 1, 2, 3. So I'm going to subtract 3. I get 1.95 times 10 to the negative 9th. Okay? And I think all those answers are in here if you wanted to double check me. All right, I think I'm done. So go ahead and hit some of the homework on this one. This one, if you know your exponents well, this might be a quick chapter for you. If not, but make sure you can get it done properly. Okay.